Good morning, students. Welcome back to experimental stress analysis class, that is module 3 and class 2. In continuation, in the previous class, we have discussed in the previous class about what is the definition of photoelasticity and what are its major applications in different fields. We have discussed in the photoelasticity. Along with this one, we have discussed the nature of light and how the light will propagate and the utilization of this light. To justify this one, we also discussed about the wave theory of light. And in continuation with the previous class, today we will be discussing about the major elements of the photoelasticity. Always, in general, the photoelasticity, which includes the major element as a polariscope. See, the polariscope is an element which converts the randomly polarized light into plane polarized light. Just look into the sketch here. Whatever the incoming light source, you can observe here, it is randomly polarized. Now, this light has to be passed through a polarizer. The purpose of the polarizer is to convert or only allow the lights which are orbitally oriented wavelength, which whenever it approaches to the polarizer, you can from here you can observe from the left to the right direction, the parallel component is passed. The parallel component, you can observe the parallel component to this plane is passed, whereas the perpendicular component is rejected. Therefore, the light emitting from the polarizer is therefore called as plane polarized light. This is the first element of a polarizing or a polarizer or a polarizing element. Its major purpose is to only convert the randomly what you call as light or whatever the now polarized light into a parallel light which is parallel to the whatever the would call as a polarizer. So here its purpose is only to pass the component which are parallel to the component of the polarizer, and it will reject what are the components which are perpendicular to the polarizing plane. Finally, whatever the light that is coming out from the polarizer is therefore called as polarized or plane polarized light. This is about the polarizer. Second one, the major important element in a polariscope is a wave plate. Here, whatever the light or the two randomly incoming light, you can observe here a light which is parallel to the plane as well as the perpendicular to the plane, which are moving in two different planes. And here the wave plate which resolves these two components, insulate into two components, or whatever the component, the two components, but in spite of this one, it will reject one of these components and it retracts or it allows a relative to the other component. See here, whatever the component which is moving, the fast axis component and the slow axis component. So here the incoming light, it resolves the incident light into two components. Whatever the incident light we are considering, it will resolving into the two components and it retracts the relative to the components. This is what the wave plate. This is the second most important element in the polariscope. Second one, third one, a quarter wave plate. A quarter wave plate, its purpose, is a permanent wave plate which induces a phase shift, that is a lambda by 4, where the wavelength of the light being light being always in perpendicular to the plane of the polariscope. So here in the figure you can observe the light which is moving along the direction of the, that is along the parallel direction of the plane, that is a quarter wave plate, and the incoming source of the light is here. So here, and this incoming light, whenever it is made to pass over the wave plate, it will be distributed into a what you call as lambda by 4, that is a quarter wave plate. So here in this direction the wave is transmitted from the quarter wave plate into mutually what you call as inclined angle here. This is transmitted light, you can observe here the lambda which is delta by, that is lambda, delta is lambda by 4, and whatever the light that is coming out from the quarter wave plate, it will be, one is the fast axis moving wave and the other one is will be the slow axis moving wave. So here the major necessity of this quarter wave plate, which induces the major phase shift, and this phase shift will be a 1 by 4 or a lambda by 4, where it is called as a wavelength of the element or wavelength of the quarter wave plate. So this is the third most important element in your polariscope. So considering these elements, we will move further, that is polariscope. Now these elements which are included in the polariscope, then we can justify the polariscope as a polariscope is an optical setup. Yes, of course, optical setup that allows birefringence or the patterns. Birefringence is nothing but the patterns or the fringes. In the earlier class I have shown what is the fringes and what is the arrangement of these fringes, which allows the birefringence in the specimen to be analyzed. The fringes which are being developed because of the loading, whatever the fringes that are developed, that can be clearly observed when we are going by the polariscope. See, this polariscope consists of the major process, what I call the elements, which I told as only the light source. The major thing is the light source, a polarizer, an optical quarter wave plate. Already we have discussed these three elements: polarizer, an optical wave plate, along with this one the specimen. And along with the specimen, we need to convert the two mutually perpendicular into a quarter wave plate. We need the optional quarter wave plate. And the second polarizer, which is called as analyzer. In the analyzer, we can observe what is the total, what I call as fringes developed in the member. So here the polariscope includes two types of polariscopes. One is the plane polariscope and other one is the circular polariscope. Let us discuss about the plane polariscope. See here, the plane polariscope consists of, one is the light source. The major thing is the light source, and this is here the light source, and the second one is the polarizer, where it converts the light wave which is parallel to the plate, and in between we need the third element is the model, where we need to observe the stresses in the model, and this stressed model is kept between the polarizer and the analyzer. And the analyzer, the fourth element is the analyzer. Through the analyzer, the observer can observe what is the stress developed in the member depending upon the fringes developed. So here in general, the plane polariscope consists of light source, a polarizer, the specimen, and an analyzer. And here always you can observe here the polarizer as well as the analyzer, both are placed in perpendicular direction or at a crossed axis. You can observe here both are placed in a perpendicular in a crossed axis. So remember this, and based upon this one you need to take the sketch and you need to also represent the sketch in your internals as well as in examinations. And here already I have told where we need to place the polarizer and where is the necessity of the analyzer. So here the first thing is the light source, where the light source is emitting from a particular point and it is moving along its axis. And to observe, to have only the light source which is along the plane of the polarizer, that is allowed. And to convert this one, the perpendicular plane light to a parallel to the plane, we need a polarizer. The second element is called as a polarizer. The polarizer which is nearest to the light source is called as a polarizer. The second linear polarizer which is away from the light source is called as polarizer. That is called as analyzer. That is the first, second, third and the fourth element. From left it is the fourth element. The analyzer where the actual what you call as display of this scattered light or what you call as fringes can be observed by using this analyzer. Here the two axes of the polarizer are always cross section. You can observe one is in a vertical axis, another one the axis is perpendicular to the analyzer is always perpendicular to the polarizer. So when the condition is here, when no light is transmitted to the analyzer and which produces the dark field. Whenever there is no light which transmits to the analyzer is the last element where we cannot, if at all there is a dark field or a dark arrangement, then it indicates there is no light transmitted through the model to the analyzer. So here the model, the other component is the model which is to be inspected is placed between the polarizer as well as the analyzer. So the polarizer is kept perpendicular to the axis of the propagation and the analyzer is always kept in the parallel to the what you call as model. This is about the brief explanation about the plane polariscope. Second one is the circular polariscope. See, which is similar to the what you call as plane polariscope. And why we have discussed about a circular and a plane polariscope? In the previous classes, we have discussed what is plane polariscope and what is a plane polarizer light and circular polarizer. In background of this one, we are discussing today about the circular polariscope. See, the arrangement somewhat similar to the plane polariscope. You can observe from the left, the light source is the first element is the light source, and the second element in general as a polarizer, and after the polarizer they are mounted with a quarter wave plate, and between two quarter wave plates there is a model, the stressed model, and the last one as usual is the analyzer where we can actually see the component. See the optical arrangement. See in general what I told, the quarter wave plate which is oriented, both the quarter wave plates are oriented at 45 degrees with respect to the polarizer, and the specimen which is after the or in between the second quarter wave plate and the first quarter wave plate on the analyzer. And one thing is here, the two quarter wave plates are generally crossed to minimize the error, and the direction of the polarization of the polarizer is assumed to be vertical. Now we shall discuss about the working principle of the circular polariscope. See, the optical arrangement of the circular polariscope is shown in the figure above. A quarter wave plate is placed after the polarizing element with its axis at 45 degrees to the polarizing axis. Now the model is placed after the first quarter wave plate. The fast and slow axis of the quarter wave plate are marked respectively as fast axis and slow axis. Then a second quarter wave plate is introduced after the model, and which is kept crossed with respect to the first quarter wave plate. Remember this. And along with this one, you remember that is the fast axis of the first quarter wave plate and the slow axis of the second quarter wave plate are kept parallel. Finally, the last optical element in the setup is the analyzer, which is kept crossed with respect to the polarizer. This arrangement is called as circular polariscope with respect to the dark field arrangement. See, the reason why which is called a circular polariscope is based on the fact that the light incident on the model in this setup is a circularly polarized. See, for this reason, we'll call it as a dark field setup. Whereas in the plane polariscope arrangement, you can observe the light incident on the model is linearly polarized. Therefore, the linearly polarized light incident on the quarter wave plate is at 45 degrees. Remember this one, to the axis of the plate. And the light which is emerging out from the polarized light is a circularly polarized light. See, the reason for keeping the quarter wave plates is the effect of the first quarter wave plate is cancelled by the second quarter wave plate, and which sync the axis, which are kept always in a crossed axis. And based upon this one, the fringe pattern observed on the screen which consists of only the isochromatics and not any isoclinics. And along with this one, since the source is monochromatic, all the isochromatic fringes appear on the dark fringes, which shows the such as it is an isochromatic fringe pattern. And what all the explanation I discussed, that is the major thing is the quarter wave plates which converts the plane polarized light into a circularly polarized light. And what is isoclinics and isochromatics we will be discussing now. See, isoclinics, if the polarizer coincides with either the first normal stress or the second normal stress plane, then the plane polarized light incident on the model at the point will emerge as the plane polarized light. So here the locus of the points which are in the directions of the principal stress coincide, then a particular orientation of the polarizer analyzer combination is known as isoclinics. See here, the light source and the polarizer analyzer axis are in what you call as mutually perpendicular directions. Now, in this one, a particular orientation, whenever the particular orientation of the polarizer and analyzer is kept, then whatever the output fringes which will be obtained, such kind of what you call as fringes is called as isoclinics. Suppose at a particular point, if the model is having the normal stress sigma 1 and sigma 2 directions, sigma 1, sigma 2 and sigma 3 stresses, in such cases, the phase difference of 2m pi will emerges, and the relative phase difference is related to only sigma 1 and sigma 2, that is normal what you call as stress directions. Suppose if the phase difference in the model is 2m pi, the model behaves as full wave plate at the particular point. And also the incident light on the screen will be zero. There is no any imitation of the light on the screen. And because of this one, you can observe only on the screen a series of small minute dark bands corresponding to the locus of the all points. You can observe here in the sketch the corresponding of the sample, whatever in the analyzer. After the analyzer, we can observe the fringes. These dark bands of fringes which are known as isochromatics. Therefore, an isochromatic is a locus of points where the values of normal stress sigma 1 and sigma 2 directions are such as to cause the relative phase difference of 2 pi m, which is known as a dark field arrangement. Therefore, the next one is the effect of stress model in plane polariscope. Now here, how the plane polariscope, the model, a stress model, how we can observe the stress model in a plane polariscope, that is been given in the sketch clearly. Now, the plane polariscope, by considering the what you call a stressed model, and this such kind of setup is called as dark field setup. So you can observe clearly in the sketch the same pattern how we have considered for a simple plane polariscope. You can observe the light source, a polarizing axis of the polarizer, and the analyzer which is kept at the extreme point, or the fourth element. In between this one we are placing what you call as, we are causing a stressed model. So this stressed model, because of the effect of the stressed model, what the output patterns we can observe, it will be shown clearly. See here, the polarized axis is in the vertical axis, whereas you can observe the analyzer axis in the horizontal. So from the polarizing axis to the what you call, from the polarizer to the analyzer axis, you can see the wave which is moving vertically will be transmitted after the model will in the horizontal axis. In the sinusoidal wave which is propagating in the vertical axis, now after this stressed model, whatever the rays that is passing, that will be moved in the horizontal axis. So that is what the rays vibrating along the planes of the principles are sigma p and sigma q, or we can take it as sigma 1 and sigma 2, two principal stresses. And finally, whatever the rays that are passing through the analyzer vibrating along its polarizing axis or retardation causes the interference. So now we shall discuss about the clear what you call as principal working of this one. So consider the arrangement shown in figure, where the source is a monochromatic light. Whatever the source we are getting is a monochromatic light. Let the polarizer, let we will give the notation for polarizer as P. P is a polarizing element and M is the model, and M, whatever the M is a model under a plane state of stress, and A is the analyzer. You can observe here the A is the analyzing element or analyzer, which is a second what you call as polarizing element. The second polarizing element, or nothing but the analyzer, is kept 90 degree to the polarizer, and the last one is the screen. S is the screen. We shall assume that through a suitable optical arrangement, the image of the model is projected on the screen. Now we shall trace the passage of the typical ray of the light through the various optical elements in the assembly. The arrangement is also shown here in the sketch. The polarizer and the analyzer are always kept crossed, but their combination can be arbitrary. Now, when the model is stressed, it behaves as a crystal, and at the point where the rays passes, the polarizing axis coincide with the principal stress axis, that is sigma 1 and sigma 2. At the point of, in the sketch you can observe here, where they are crossing, it behaves as a crystal. At the point where the ray passes, the polarizing axis coincide with the principal stress axis, that is sigma 1 and sigma 2 at the point. In general, the polarizer makes an angle phi with the normal stress axis. In this condition, if phi happens to be 0, that is phi by 2, if the polarizer coincides with either sigma 1 or sigma 2, then a plane polarized light incident on the model at that point will emerge as a plane polarized light. Now look into the sketch here, where since the analyzer is kept crossed with respect to crossed in this direction, you can observe here the analyzer is kept crossed with respect to the polarizer. Then the light emerging out of the analyzer with respect to the polarizer is coming out of the analyzer is 0. Now, consequently, if all the points of the model where the direction of the principal stress, if the direction of the principal stress happens to coincide at a particular orientation of the polarizer and analyzer combination, then the light which is coming out of the analyzer will be 0. Remember this point, the light which is coming out of the analyzer will be 0. Suppose if the polarizer and analyzer combinations happens to coincide with the directions of sigma q and sigma p, then the stresses at one point of the model, then in general there will be a locus of points in the model along with this dark condition is satisfied. So this is, in general, the stresses are distributed in continuous manner. This is what the plane polarized, the effect of the stressed model in a polariscope. This is a dark field arrangement, and even in the examinations you need to represent with the sketch as well as this arrangements, how we are orienting the analyzer as well as the polarizer. See that what again the points I given here. The model is inserted and viewed through the analyzer, and the polarizer is always kept perpendicular to the axis of the light of propagation. And here, based upon this one, the transmitted light waves comes only on the axis. The analyzer is always kept 90 degree or perpendicular to the polarizer, which will transmit the light. And now for this one, hence whatever the light that is coming out of the model, which will be vibrating at an vibrating components, and that components we can consider it as A4 is equal to A cos omega t plus delta cos phi. So on entering the analyzer, only the components along the A6 directions are allowed. Then we can rewrite the equation, that is as A6, whatever the light in a 6 direction, we can write it as A6 is equal to A4 sin phi minus A5 cos phi. Now rearrange this equation such that it will be in terms of omega t and delta t. That is what A6 is equal to A cos omega t plus delta into cos phi sin phi minus A cos omega t sin phi cos phi. Or we can even write it as A6 is equal to A by 2 sin 2 phi into cos omega t into cos delta minus 1 minus of sin omega t sin delta. And on simplification, we can get the equation as, we can reduce the equation as A6 is equal to minus A sin 2 phi sin delta by 2 sin of omega t plus delta by 2, or A6 is equal to minus B sin omega t plus delta by 2, where B is A sin 2 phi into sin delta by 2. See, this is what the amplitude of emerging light which is coming out of the analyzer, and A measuring of the instant light. Now similarly, what is the effect of the stressed model in circular polariscope under dark field arrangement? See here, the working principle or the major components as you have observed in the previous plane polariscope, here also you can observe the similar components. See, the optical arrangement of the sketch of the circular polariscope with the stressed model is shown in the figure. Here, the optical arrangement which shows in the figure, which includes a quarter wave plate, that is a fast axis and a slow axis quarter wave plates, is placed after the quarter wave plate is placed after the polarizing element with the axis of 45 degrees to the polarizing axis. And here, along with this one, 2 quarter wave plates which is placed after the model, that is before the model and after the model. Along with this one, you can observe the analyzer which is emitting the light, that is a linear polarizer. It allows only the linear polarizer. Similarly, the second analyzing, which is called as analyzing the polarizing plate, that is called as analyzer, which is kept in the vertical axis of the polarization. Now the model is placed after the first quarter wave plate. This is the first quarter wave plate, and the model is placed after the first quarter wave plate. The fast and slow axis of the quarter wave plates are marked respectively as fast axis and slow axis. Similarly, a second quarter wave plate is introduced after the model and it is kept crossed always with respect to the first quarter wave plate. The second quarter wave plate is placed always in cross section with the first quarter wave plate. It is the fast axis of the first quarter wave plate and the slow axis of the second quarter wave plate are kept parallel. Remember this point, because only by this condition we can emerge the light on the analyzing element. And lastly, the last optical element of the setup is the analyzer, which is kept crossed with respect to the prost. This is vertically, which is kept crossed with respect to the polarizing element. This arrangement is called as circularly polariscope or circular polariscope with a dark field arrangement. See, why we need to call this one as calling as a circular polariscope is because which is based on the fact that the light incident on the model in this setup is circularly polarized. Whereas in the polarized polariscope, that is a plane polariscope arrangement, the light incident on the model is linearly polarized. Therefore, the linearly polarized light incident on the quarter wave plate is at 45 degrees to the axis of the plate and which emerges as circularly polarized light. Further, in the absence of the model, the effect of the first quarter wave plate is cancelled. Whenever there is no object in between this, the effect of the quarter wave plate is cancelled. Hence, the background is a dark and the setup is called as dark field setup. And also, the fringe pattern observed on the screen will be existing only the isochromatics and there will not be any isoclinics. Since the source is monochromatic, all the isochromatic fringes appear on the dark fields. So here, the circular polariscope which employs a circularly polarized light, the first light element, as I told, is the light source which is called as a polarizer and which converts the ordinary light into the plane polarized light. Similarly, the second wave plate, quarter wave plate, is a quarter wave plate which is angled at a pi by 4, that is 45 degrees to the plane of the polarization. Similarly, the second quarter wave plate which converts the circularly polarized light into plane polarized light. Now, the light vector which is emerging from the polarizer can be considered as A. A is equal to A cos omega t. And here, since it is a quarter wave plate, I will take it as first A1E as A cos 45 degrees. Similarly, the second light vector which is flowing, that you can count as A2E as A cos 45. Or we can even rewrite as A cos omega t of 1 by root t. Similarly, A2 also can be written as A cos omega t 1 by root t. Now, A1 of the light emerging, we can write it as cos of omega t plus pi by 2 into A by root t. And the second element of the light source, I can take it as A21 is equal to cos omega t of A by root t. Similarly, when the light vector entering the model, I will be resolving into the two components, that is A and B, where A can be written as A1E of cos theta minus A2t sin theta. Similarly, I can write for the second component which is moving in the horizontal directions, in the vertical direction I can consider it as A by root t into cos of omega t plus theta. And the third element, the light vector entering the analyzer I can take it as Ax is equal to A31 of cos 45 minus A41 of cos 45. Or we can even rearrange this one as Ax is equal to A cos omega t plus 2t, 2 theta plus delta t by 2 into sin delta by 2. Thus, the polariscope eliminates the isoclinic fringe pattern. That was already in the theory part I told. This polariscope eliminates the isoclinic fringe pattern and which returns only the isochromatic fringe patterns. Today we'll end up with this topic. Tomorrow in the next session we'll come back with the new topic, that is how to produce the fringe pattern in a what you call as polarizing element. Thank you.